Okay, welcome to class. On Friday, I had gone through the examples for irregular shapes and I assigned assignment 3 to you. So hopefully you had time to work on it. If you didn't, that's fine. You work in at your own time and you can check your answers later on when you're ready. So Friday we learned about composite shapes, like shapes that are created from our four main shapes, the square, rectangle, circle, triangle. So we can actually make up a whole bunch of different shapes by just putting two rectangles together, for example. We also learned it on a related type of question about shaded areas. So shaded areas also comprise of a couple of our main shapes. In example 2, you can see we've got a rectangle mixed in with a couple of circles. So all you have to do to find area of a shaded part is to be able to find the area of the rectangles and the circles. For shaded areas, we end up subtracting the inner shapes because we don't want the areas of the white spaces. We just want the shaded part. So that's one way to do it. Sometimes our shaded part comprises, there is no white shape to subtract out, but the shape itself is just a portion of an original shape. So if you can recognize that this is 3/4 of a circle, you can just find 3/4 of the area of the circle in question and easily calculate that. Example 4 was sort of similar to that. So I said that I would go over all the questions on assignment 3. So if you've done the assignment and you have no questions or problems, then you can ignore this video. If you did have some questions on the assignment, then please pay attention to what I'm going to go over, and hopefully it'll make sense when I go through a few of these questions. So first of all, we've got find the area of each of the figures shown. 1A, I can see I've got two rectangles together. So we did an example like that. I don't have the formula for an L-shaped polygon, but I do have the formula for rectangle. So if I look closely at this, to me, I see two rectangles. I either see them side by side or one on top of the other, and it really doesn't matter. You could cut your rectangles this way, or you could cut your rectangles this way. I don't know, my mind works more like this. So I'm gonna cut my rectangles, kind of separate them by just putting a line here. Therefore, I have area number 1 and area number 2. Now you have to know what this notch system means. That means these sides are equal. So if this whole distance is 12, that means that this must be 6 and this must be 6. Okay, that helps me out immediately. For area number 1, I really didn't need to know that, but area number 1 is very easy to see. Area number 1 equals just 12 times 20, which is 240 kilometers squared. Now let's see area number 2, might be a bit trickier. Let's see. So I've got 6 by, now I don't know this length, right? I know that the whole side, this whole long side is 50. Well, if this side is 20, then just by doing some simple math, 50 minus 20, this side is 30 kilometers. That wasn't so hard, right? So area number 2 is going to be 30 by 6, which is 180. Remember, area is always in units squared. Then I add these up, and I'm going to get 420 kilometers squared. So really not that challenging if you followed the examples on the previous pages. Okay, 420 kilometers squared is the answer. Now, if you would have separated the rectangles up the other way, and you saw them as two stacked rectangles, like on top of each other, that's fine. You're going to end up with different areas in the constituent parts, but you're going to end up with the same final answer because it's the same shape. Now for 1B, I have an odd looking shape. It sort of looks like a football field or a soccer field. More importantly, I see the area, see a rectangle and I see a circle divided in half. So if I find the area of the rectangle, and then the area of the circle, now it is two half circles, but together they make a full circle, right? So if I just have to find the area of the circle, the area of the rectangle, add those up, and that will give me the total area. So the area of the rectangle is very straightforward, 200 times 80. And it's meters squared. Now let's see, area of a circle. Remember the area of a circle I need, it's pi r squared. So I need the radius of the circle. I know that the diameter is 80. Radius is half of that. So area of the complete circle, right, if it was put together, would be pi times 40 squared. Definitely need your calculator for this. So pi times 40 squared is 5026.55 meters squared. Add them up, and I get, some black pen, 21026.55 meters squared. Okay. And then finally, the last one on this page, this is just kind of an odd, just goofy shape that was made up by us. So we have a half circle. I see a rectangle here, right? I see a half circle, a rectangle, and a triangle. I'm just going to lightly put in my. So I've got three shapes that I have to find areas of. So area of a half circle. How am I going to find area of a half circle? Well, how about just find the area of the whole circle and cut it in half, divide it by 2. So the radius then, if the diameter is 30, the radius is 15. Okay, so area of a half circle, it's going to be pi times 15 squared divided by 2. And that gives me 353.43 feet squared. Okay, so now I'm going to do my area of rectangle. Those are usually straightforward. Kind of what you see is what you get. Well, that's just 30 by 30. It's actually a square, right? It's a special kind of rectangle, a square. It's actually a square. It's not wrong to say it's a rectangle. A square is a special case of a rectangle. So 30 by 30 is 900 feet squared. And finally, area of the triangle. Okay, what's the area of the triangle? So base times height divided by 2. Well, what's the base? That's easy, right? The base is 30 feet. But I have to find the height. So what's the height? You know what? Sorry, I'm going to move this over a little bit. Shouldn't have done that. I'm going to say the base equals 30 feet. And this is the height, right? The height equals, well, let's see. I'm not given the height directly, but if I know that from here to here is 70, this is 30, and then this has to be 15, right? So this piece from here to here is 15. From here to here is 30. So what's the leftover? This piece has to be then 70, take away 30, take away 15. So 70, take away 30, take away 15. leaves me with 25. So the height is 25. Okay, so area of a triangle is base times height divided by 2. And we get 375 feet squared. So the total area is just the 3 shapes added up. And we get 1628.43 feet squared. Okay, so that was a little more challenging, I think, than the other two, perhaps, because of those funny shapes. And you had to dig a little bit to get the height for sure. Let's move on to shaded areas. Pretty much the same procedures. You're just, instead of adding shapes up, you're subtracting shapes. So find the shaded area. So we just want the area of these weird little shaped pieces, which we don't have formulas for. Now, there's a big assumption here that this is a square. We should have actually put these little notches in. So for shaded areas, what we're doing is we're not adding the 2 shapes together, we're subtracting. So we're going to find the area of the outside shape, the area of the square. Then we're finding the area of the circle. And we're doing a subtraction. So 8 by 8 is 64 centimeters squared. So once again, if you think about it, all the way across the circle is 8. So halfway across the circle has to be 4, which is what we're interested in. So the radius equals 4. Pi times 4 squared equals 50.27. So area of shaded part only. It's a subtraction. So 64 subtract 50.27 is 13.73 centimeters squared. I'm just going to put in brackets subtract. Okay, so that's the area of the shaded part. So the skills are the same, right? We find the areas of the separate shapes, but instead of adding, we subtract. So you're taking the outside shape, subtracting all the inside shapes. So here I have kind of the backwards. I have area of circle, and I'm going to subtract area of square. And again, we didn't do a great job of telling you this is a square, but we should have had little notches. Okay, I'll do the square first because it's so easy. 10 times 10 is 100 feet squared. Now here, what do I get here? Pi times 12 squared, because 12 is the radius. So that gives me 452.39 feet squared. And I'm going to do a subtract, and that's going to give me 352.39. Okay, so, oops, sorry. Let's keep going. Now this one is odd, right? What do I have here? I've got the area of a square. And at least this time we got the notches to tell you it's a square. So that's another 8 times 8, which is 64. Remember those 2 little notches mean inches? And I'm actually going to write the word out because the two little notches with the 2 beside it doesn't really look, it's not easy to look at. And now I'm going to subtract out the area of the area of the triangle. So what do I need? I need the base, which is 8, times, what's the height? Well, this would be the height. It always has to be taken from a perpendicular to the base. So this would be, let's see, well, it's halfway across, so that must be 4. So area of the triangle will be base times height divided by 2. That's going to give me 16 inches squared. So I'm going to do a subtract. 64 subtract 16. I get 48 inches squared. And the 48 inches squared is the area of this shaded part. It's kind of a weird shape, right? And then finally, the area of these little shaded pieces. So what do I see? I see the area of a rectangle. And then the area of, all the circles appear to be the same size. I'm going to assume that. 1, 2, 3, 4, 5, 6, 7, 8. Area of 8 circles. So that's not hard to do, right? Find the area of one circle because they're the same size. I multiply by 8, and that would be the area of 8 circles. Now, this seems a bit tricky until we kind of think about what circles represent. So if this whole distance is 6, that must mean the distance from here to here is 3, right? And the distance from here to here is 3. Well, that also means that, the diameter of this circle is all the way across here is 3, right? So from here to here is 3, and another 3, and another 3, and another 3, 3, 6, 9, 12. So this whole distance must be 12 centimeters. So the area of the rectangle is 6 by 12, which is 72 centimeters squared. Now, let's see. If the diameter is 3 centimeters, then the radius of any one of these circles is half of that, and it's 1.5. Okay, so the area of one circle is pi times 1.5 squared. And then 8 of them would be multiplied by 8, right? 8 times this. Okay, so I'm going to do this all in my calculator at once. So pi times 1.5 squared times 8 gives me 25.5 centimeters squared. Now remember, we want subtract. 72 subtract 56.55. I'm just writing the word because sometimes my little subtract symbol might get lost. So we end up with 15.45 centimeters squared. And the only way that I could calculate that is by doing kind of a backdoor approach, doing a subtraction method, because we don't have any formulas for these odd little shapes to add them all where the shading is. So that's it. Hopefully you got most of your answers correct if you did this before I went over them. I'll post the answers on the blog. Tomorrow we'll talk about perimeter and area applications, and then we will see about moving through this unit, maybe trying to get another test in before school ends. So that's it for today. I'll talk to you tomorrow.